Project 2.8, the RPN Calculator. The RPN Calculator is essentially a basic four-function calculator which uses postfix notation. Postfix notation, or reverse Polish notation, hence the name RPN, is a really strong and efficient mathematical notation that eliminates the use of parentheses during calculation and makes math more efficient. It essentially puts the operator behind all of the operands. And this calculator also operates via a abstract stack data structure, which follows a strict last in first out order and supports two primary operations: push, which adds an element to the top, and pop, which removes the top element. Let's see a demonstration. So first we put a random number in, let's say 6.12. We push that into the stack. And then we do, let's say 1.537. And we also push that into the stack. And then let's pick an operator. Let's just say plus. And then here you get the result. This calculator also shows up errors if things are inputted incorrectly. Let's say, for example, you put 2 decimals. And it would show up as multiple decimals. And let's say we do a divide by 0 error. In this case, I would do a 0, enter it, and then divide. And then you would then see the divide by 0 error. There's also a, let's say, for example, I put less than 2 operands inside the stack, and I hit subtract directly. You would say that the stack has less than 2 terms inside, and it would fail to perform any operation. Let's look at the code of this project. In the first slide, you can see that we included a stack.h library, which is a custom library. And inside this custom library, we have some various functions that we use in our INO main code. One of them is the push function, which adds a float to the top of the stack. And then there is a pop function, which removes or returns the top value inside the stack. And then we have a peek function, which reads the top value without removal. And then we have a isFull and isEmpty functions, which validate the stack's limits, checking if it's full or is it empty. Next, we have some different analog thresholds. This is for the user input, which is in this case the one-wire keypad. And these are different voltage thresholds that we measured from the voltage divider. Since the keypad is a one-wire keypad, each button has a unique combination of resistors it needs to go through in order to go from power to ground. And this is how we obtain these different thresholds, in order to know that whichever button the user pressed. The main loop function, we also have various different if statements, else statements in order to show the different errors, such as the error stack is less than 2, or the error divided by 0. And in the code, I also used some buffers, which are temporary character arrays, in order to increase the modularity of the code and just to make it look more organized and easier to manipulate the data. That's it for my project. Thank you very much for listening.